Now we're going to be talking about a chain rule, and essentially what it is it's this thing that if you have, let's say, this dy by dx, then you can basically write it as this dy with respect to something else. Let's call that something else a circle, and a circle could be anything multiplied by, and I'm just using a dot to represent multiplication over here. Nothing crazy going on. And then this circle with respect to dx. And what I'm doing over here is I'm just going to go over this chain rule, and what it's doing is it's basically taking these three quantities. It's taking this y, this circle, and this x, and it's relating all of these quantities. And I'll just write this thing down over here. So we've got a y, a circle, and x. And essentially it's relating these two quantities. So it's relating the first quantity and this last quantity using this intermediate quantity. And so this it says that this dy by dx is sort of equal to this dy with respect to this d circle. And remember, a circle could be anything, right? Any other quantity multiplied with this d circle over dx. And it makes sense because if you go ahead and you look at this expression that I just wrote over here, then one way you can sort of see it as is you can say, well, okay, this is a circle, this is a d circle. They're the same thing, and since the fractions are being multiplied, what I can sort of do is I can cancel these two out, and I'll just be left with the dy by dx. And yeah, that's one way of looking at it. So that's where sort of this chain rule becomes really useful. And now you may ask, well, what's the purpose of this? Why do I need to know the chain rule? And why do I need to know this? This is a really cool thing over here that I just drew over here. So why do I need to know this thing? Why do I need to know the chain rule? Well, it's because it allows you to basically relate three quantities at the same time. And one place where this is really useful is, let's say you have something like this, where you have y is equal to under root x plus 5, and you're sort of supposed to differentiate this with respect to x. So what I mean by that is, let's say I'm supposed to differentiate this equation with respect to x, and so I just basically apply my differentiation operator. I'll have my y inside over here, and I'll do the same over there, d by dx, and all of this is going to be under root x plus 5. So I'm supposed to do this, right? And so this is basically going to simplify to dy by dx equals this thing, which is d by dx, and then I'm supposed to sort of do something with this guy over here. And then one way I can make it simple is I can change that surd to a power, and if I do that, I'm basically going to get x plus 5 whole power of 1 by 2. Now, how do you differentiate this? Now, you may be like, well, isn't this the constant? Well, no, it's not the constant. But when we were talking about the constants, like, let's say 5x squared, or let's say 1 by 3 x to the power 4, in these cases, the constants are being multiplied to the variable x. All right, over here, it's being added. It's not the same. When a constant is being added, it's not the same. You can't just sort of pop it outside this differential. And then the second thing that I want to talk about over here is that this plus 5, not only is it not multiplying with this x, it's also inside of this bracket thingy. And this bracket has a whole power of 1 by 2. So it's like you can't even do anything inside of the bracket unless you take care of the outside of the bracket and the power on the bracket. So how do you deal with a differentiation like this? And this is one place where chain rule comes in really handy. And I'll just show you this example, and then maybe in the next few videos we'll sort of do more examples. But one thing I can do over here is I can use the chain rule. And what the chain rule says is it basically gives me this idea that I can relate these three quantities. So what I can do is I can just say, well, okay, if I want dy by dx, and what I can sort of do is I can sort of take two different differentiations. One of them could be dy with respect to a d circle, and then another one could be a d circle with respect to dx. And then if I multiply these two things, I know that my answer has to be dy by dx, because I cannot solve this directly. I don't know how to solve this directly, but I do know another way of getting my dy by dx is if I have this thing and I multiply them together. So that's what the chain rule tells me, and I use it really carefully. So I have this dy by dx. I have this guy, x plus 5 whole power of 1 by 2. And what I do is I basically, really carefully, I just turn all of this into a circle. I say that a circle is equal to x plus 5. And so now what I've done is, see, if I just erase all of this, even all of this over here, what I've essentially done is I've sort of done something really genius over here. I'll just grab this thing, and I'll take it over here. So this circle is equal to x plus 5. And what I can say is that this y is going to, oops, or I can do it over here, this y is going to be equal to x plus 5, and I already said that x plus 5 is a circle, so this y is going to be equal to this square root, and inside of that square root I'm going to have this circle. Now this circle may be confusing you. Maybe you guys are thinking, oh, that's a 0 and it's not a circle. So instead I'm just going to use another shape. I'm just going to use a triangle just to sort of let you guys know that it really is a shape. So what I've done is I've said that x plus 5 is equal to this triangle, and now that allows me to do is I can basically differentiate I can differentiate this y with respect to a triangle, and then I'll do the same thing over here, and I'm basically going to have this thing. And so what I can do is, this is a triangle, that is a triangle. I can differentiate them both using the power rule. So I'll just have sort of this thing where I'll have this triangle. I can sort of change that surd into this power. And then what I can do is I can say that dy over d triangle is simply just 1 by 2 triangle, and then 1 by 2 minus 1 would just be minus 1 by 2. So it's this thing. And then what I can do is I can say, okay, well, what is this so what I've done is essentially, if I just go back over here, what I can do is I can sort of put out these circles in place, triangles in place of them. What I've done is I've basically found out this first bit, okay, this first bit over here. And now what I need to do is I need to sort of find this second bit. And so how do I find the second bit? Well, I find the second bit through this equation I made. I say, how does my triangle change with respect to x? And so this is going to be this thing. And now what I can do is I can say, well, this d triangle over dx is just going to be, well, now I sort of have this thing and I sort of have that thing. So how do I differentiate this? This is something we've not done before. This is something that's new. So let's look at this. Now this plus 5 is not a constant that's being multiplied to this x. So it's not going to go out of this differential operator. You cannot do that over here. If this 5 was being multiplied to the x, then yes, you could have done that. So when it's not being multiplied, then you just take this thing over here and you take this thing over here. And then basically, in other words, what I'm trying to say is I'm trying to say that you basically apply the power rule on this guy as well as on this guy. And you can be like, well, I understand that the x has a power of 1 on top of it. 5 doesn't have any x next to it. So how do I apply a power rule on that? Well, like it does have an x next to it. And the way it does is because it has an x next to it, but that x is being raised to the power 0. So what is x to the power 0? X to the power, anything to the power 0 is just equal to 1. So it's simply 5 raised to the power x, 5 multiplied by x raised to the power 0, and this thing just becomes 1. So your answer is just 5. But that doesn't mean it doesn't have an x next to it. So it does actually have an x over here, and it's raised to the power 0. So what I do over here is I can just apply power rule on both of these guys. So let's sort of do that. So for the first one, I'm just going to get that 1 is going to multiply down here, then I'm going to get an x, 1 minus 1. So that's just going to be 0. And this thing is just going to become 1. So my answer is just going to simplify to 1. And then this thing, well, what does this thing become? This thing is just going to become, it's an x raised to the power 0, right? And so what I can sort of do is if you want to differentiate this guy, what you can sort of see is that we can sort of write it as something like this. Okay, if that makes it any simpler. And so because what we are doing is we are differentiating this guy and we are differentiating this guy. So you can denote it like this, like we're differentiating 5 multiplied by x to the power 0. And so now the 5 is being multiplied, so you can pop it out of this differential. That's just going to be this thing. Now you have your x to the power 0. And so it's just going to be, now it's just going to be 0x, 0 minus 1 is just going to give you minus 1. But this 0 that you have over here, it's just going to make this entire term equal to 0. So all you're going to be left with, is simply this 1 over here. So that's what you've done. You've basically found out not only this first part, you've also found the second part. And the second part is right over here. And so now what you can do is now you can just say, well, oh, my dy by dx is just sort of equal to this dy with respect to this d triangle. And it's being multiplied with this d triangle with respect to dx. And you know what both of these things are. So this thing is basically 1 by 2 triangle minus 1 by 2. And then this thing is just 1. And of course you have your dy by dx over here. And so now what you can do is now you can simplify this, and you will just get 1 by 2 triangle minus 1 by 2. And you know what this triangle is. So this, if you go back all the way over here, this guy is what you put equal to as your triangle. What you need to do is you can just substitute all of that stuff back in, and it's going to be 1 by 2 x plus 5 minus 1 by 2. And there you go, you have all of that differentiated. So you had this thing, and you basically used this chain rule to sort of differentiate this. And the way you did it is you just put the thing, this bracket thing, this thing inside the bracket, just put this equal to a triangle, and you just sort of differentiate it like that. Now this is a little tricky, and it takes a lot of time. In the next video, I'll be showing you a much simpler version of the chain rule that is way more easier to use.